Chapter number 1, Real Numbers, Exercise 1.1, question number 2. Question 2 says, show that any positive odd integer is of the form either 6 cube plus 1, 6 cube plus 3, or 6 cube plus 5. To start with, let us first observe these numbers, these expressions over here, 6 cube plus 1, 6 cube plus 3, and 6 cube plus 5. Now, let us first write down quickly about what was the Euclid division lemma. So according to the Euclid division lemma, we have for any integer a, if I'm dividing any integer a with the integer b, I can write the integer a as bq plus r, where q is my quotient and r is my remainder. And also the remainder obviously has to be greater than or equal to 0, and it should be less than my divisor. So again, for any integer a dividing by b, I can write it as a is equal to bq plus r, where q is quotient and r is my remainder, and r is in the between 0 and my divisor. Now look at these expressions, 6q plus 1, 6q plus 3, and 6q plus 5. They're sort of looks like this bq plus r, where if I let the b my 6 and r the remainders to be 1, 3, and 5, q could be quotient. So why not let's do this. Okay, so the question says, let us read the question again. Show that any positive odd integer, what are the underlined keywords? Positive odd integer. So if I let any positive integer, suppose any integer, any positive integer a, let a be the, let a is greater than 0 we have, that means a is positive integer and a belongs to z, that means it is integer, greater than 0 it means positive. Now I can write it as a is equal to, according to this rule, according to Euclid division lemma, we can write a as bq plus r, bq plus r. Now what about if we have this, if I am dividing this a, if I divide any number, suppose 7, if I divide any number 7 by 6, now why I'm doing with 6? Because 6 is over here. So if I divide any number by 6, let's see what will happen. So let me divide 7 by 6, 6 times 1 is 6, remainder is 1. So what is the value of a? So a can be written as 6q plus 1. Remember, a is my any integer. Now I'm letting different integers to be a. So if a to be 7, then a can be written as 6q plus 1. If a to be 8, I'm dividing 8 by 6. 6 again, 1 is 6, remainder is 2. Now a can be written as 6q plus 2. Similarly, if a to be 9, the remainder that I will get would be 3. Okay, so some pattern is there. Now if my a to be 10, then the remainder obviously would be 4. If a to be 11, then remainder would be 5. If a to be 12, there won't be any remainder. There won't be any remainder. Okay, now look it over here. Very important things. Very important things. So after 13, I can write a is equal to 6 into 2, 12 plus 1. Obviously, it will look like this. Now, what is my idea over here? Our idea is that, let us read the question again. Why not? Let's go to the question again. So the question says, just a second. Yeah. So the question says, show any positive odd. So we took the positive integers, so tick for it. But we haven't considered till now about the odd integer. What was the odd integer? The a. But what about the odd integer? Now we are going to look forward to it. Okay, look it over here. So a can be written as any positive integer we know can be written as 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5, or 6q. Now we have to choose the odd integer. Let us see. If I am writing a is equal to 6q, 6 into q, it's a odd integer or an even integer. It should be an even integer, multiple of 6. plus 1, but right now it is 6q plus 1, so it would be odd integer. So this is odd integer. What about this? Till 6q it is a even, plus 2 again even. So in this case, if a would be equal to 6q plus 2, for example, if a would be 8, then my a would be even. We are considering the odd, so this won't work. Similarly, 6q plus 3, it is a odd. 6q plus 4, it is a even. 6q plus 5, it is a odd. And 6q even. So let's rub these ticks. Just a second. Yes. So what do we get? We got that any integer, so any positive, we consider a should be positive integer. Any positive odd integer can be written as either 6q plus 1, 6q plus 3, or 6q plus 5. So we conclude that we have shown that any positive integer, odd integer, is of the form either 6q plus 1, 6q plus 3, or 6q plus 5. That's all.